Today we're going to talk about absolute value. And then one of the most important things about solving absolute value equations is that you will have two solutions most of the time. You might have zero solutions, and every once in a while we will have one solution. But you need to solve two different problems. Step one in doing these problems is to look at this. Once your absolute value is isolated, the only thing on the other side of the equation is the absolute value, you check out this number. And if it's positive, you're good to go. If it's negative, there's no solution, and we'll show how that works. So what we're going to do is we're going to solve two equations. Because if you imagine this, you already know that the absolute value of 8 is going to equal 8. But you also know that the absolute value of negative 8 is also still 8 spots away from 0. So what we do is we solve two equations. We solve the normal one, which is x equals 8. And then we solve the other one, which is the negative version of that, equals 8. Since nobody cares what negative x equals, we're going to multiply both sides of this equation by a negative 1. Some of you like to think of it as dividing both sides by negative 1. It's the same thing. So if I hit this with a negative 1, negative times negative is positive, and negative makes that negative 8. And we get the answers we had just found earlier. X is going to be equal to 8 and negative 8. So let's try this out with example A. If you have 6 times some number equals 12. Well, we also know that we need to solve for the negative version of this. And I'll show you a different way in class of how I like to think of it. But this way, you will never get the answer wrong. So we're going to start our tree branch. The absolute value is all by itself. This side of the equation is definitely positive. So we're going to solve 6k equals 12. And we're going to solve the negative version of this equals 12. I'm going to get rid of my parentheses here, and I'm just going to make that negative 6k equals 12. And when I go to solve this, I divide both sides by negative 6. That makes that 1. And k is going to equal 12 divided by negative 6, which is negative 2. Going back and solving the original problem, which is nice and easy, we're just going to divide both sides by 6, and we're going to get that k is equal to positive 2. So in this case, k is equal to 2 and negative 2. Now, normally you would see it written like this. They like to do it in numerical order. If we check out this other one, though, B, you're going to see that the answer is not going to come out to be something and the opposite of itself. It's going to be two different things. So let's try it out. Let's use this nice handy orange. And we need to solve this problem for this 18 and for the negative version of it. So our tree branch is the original problem, n plus 9 equals 18. But before you start solving that, already write the other one, which is the negative version of it. And you must put parentheses. We're going to solve both of these. It's almost easy to see the answer. What plus 9 equals 18? You guys already know that the answer is just going to be 9. But let's just do it all the way out. Let's subtract 9 from both sides of the equation, and we're going to get that n is equal to 9. Now over here, you could distribute the negative. But what I'm going to have you do when you're solving absolute value equations and inequalities is we're going to get rid of this negative right now. I'm going to multiply this side by negative 1, making that go away. And I'm going to multiply this side by negative 1. So now I'm going to solve for what happens when it's negative 18. And if there's a plus sign out here and nothing else, we can just write n plus 9 equals negative 18. If we want to solve this problem, for those of you like the wall, let's put it in. We need to do the opposite of plus 9, and the opposite of adding 9 is subtracting 9. So let's subtract 9 from both sides. And now we get n is equal to negative 27. Remember, when they have, I'm going to use a different color here, when they have the same sign, you add, and then you keep the sign that you were using, which is a negative. So n is going to equal, in this case, 9 and negative 27. So you can see you don't just want to solve it and say, oh, x is going to be 9 and negative 9. It doesn't work like that, only when it's multiplication. So again, if you plugged them both in, they would work. 9 plus 9, absolute value, totally equals 18. But so does negative 27 plus 9, because negative 27 plus 9, is equal to negative 18. And negative 18, when it comes out of the absolute value bars, is a regular 18. So we're going to try a couple of more. In this next one, we have 3z plus 21 equals 27. Again, the absolute value is all by itself. So all we have to do is check this side. Is this side positive? Great. So we're going to do 3z plus 21 is equal to 27. And we're going to solve for the opposite of that. Equals 27. And again, you will be able to distribute that if you like to solve it that way. We'll try it out in class. In this case, we have, let's put in our little line. The z is attached to a 3, so we don't want to involve ourselves with that. We want to get rid of everything besides this z. So I'm going to get rid of the 21 by subtracting it from both sides. And I'm going to be left with 3z is equal, I do a subtraction problem, and I get 6. Now, what is the opposite of 3 times z? We're going to divide both sides by 3. And when we do that, we get that z is equal to 2. So that's one of our solutions. Remember, there's almost always a second solution. So here, I could distribute the negative, or I could just multiply both sides by negative 1 and make this negative go away. And I have to multiply that side by negative 1. So again, I'm solving for the 27 and the negative of it, the opposite of it. So now I've got 3z plus 21 is equal to negative 27. This time when I subtract 21 from both sides, I'm left with 3z plus 0. And I have the same sign there, so I'm going to add these two numbers together to get 48, and I keep the sign. It's negative. Now, 3 goes into this evenly. And I'm just going to let you know that it goes in 16 times, so we're just going to go with it. And we get negative 16. So our two solutions for this, for z, would be 2 and negative 16. And again, normally they like them written in numerical order, but it's okay that you have them written that way. So our very last one is a trick. And this is why I was saying step 1, isolate the absolute value. It's all by itself. Nothing else is over there. Step 2, check out this number. Is it positive? No. So this problem has no solution. You're done. If this number is negative, you cannot do the problem because there is no value that's going to come out as a negative. Remember, if you think of this as a distance, is the distance from 0 negative 4? Because that sounds a little ridiculous. You can't have a negative length. So this has no solution. And you get to stop. So you guys try out the two below, and let's see what you get for your answers. For 1, you should get y is equal to negative 8 and 6. And for 2, we should get that x is going to be equal to negative 7 and 4. If you didn't get both of those solutions, go back and try it out and see if you can get that to happen, and bring any questions you have to class tomorrow.